With a sphere of 4,000 miles radius being spun round once every 24 hours, a little bit of calculations will show that that person there is being spun round at about 1,000 miles an hour and doesn't know it. I mean, this is obvious nonsense. You go on a merry-go-round and it goes, I doubt, more than 10 miles an hour, and you get off all dizzy. You mean to tell me that people can be spun round at approximately 1,000 miles an hour and not know it? Why, if this is so, this whole room that we're in is supposedly being spun round at something of approximately that order of speed, and we don't know it.
Beneath the marble floor of Frombork Cathedral in northeast Poland is the dusty crypt where local legend says astronomer Nicolaus Copernicus is buried. Copernicus, the man who put the sun at the center of the universe.
Copernicus is what I call a reluctant hero, because he was not really trying to change the world the way things happen. He was actually trying to go back to Plato, in a sense, and restore this classic Greek sense of harmony to the cosmos.
Copernicus, born in 1473, was schooled at a time when classical ideas were again ascendant. Copernicus studied law and medicine. But after his uncle became the bishop of the northernmost diocese in Poland, he arranged for Copernicus to become a canon of Frombork Cathedral, ensuring a lifelong position.
Copernicus was in fact sent to Italy to graduate school to study both regular law and canon or church law. But while he was at it, he got some tutorials in astronomy, but all the time he was keeping up, buying astronomy books. And that was very important because Copernicus did live in the early days of printing, and it made it possible for him to get a lot of material that way.
Copernicus was troubled by the Ptolemaic Earth-centered system that was almost universally accepted during his lifetime. It required complex heavenly mechanics called epicycles to explain the seemingly odd motions of the planets. But when Copernicus tinkered with Ptolemy's model, placing the sun at the center of things, he found a much more aesthetically satisfying result.
What Copernicus realized is that once you move the sun to the center and you order the planets according to how long they take to go around the sun, then you have this beautiful harmony.
Although Copernicus was correct in putting the sun at the center instead of the Earth, he was motivated not so much by scientific observation, but by his concept of beauty and simplicity. He wrongly believed the planets circled the sun in perfect circular orbits.
The Copernican picture was simply wrong. It had to be adjusted. So in order to get the right motion of the stars and the planets, you had to add little cycles. It became quite complicated.
Nevertheless, Copernicus got much right. To further explain the motion of the heavens, Copernicus correctly believed that the Earth rotated on an axis, or pivot point, every 24 hours, creating the illusion of a setting sun and traveling stars. Though correct, this was counterintuitive.
The whole thing was completely ridiculous. If the Earth is spinning around every 24 hours and you throw a stone up into the air, it's going to land in another county. And think of the poor birds. So Copernicus was going against all common sense.
Perhaps because of this, and because his sun-centered or heliocentric system might be considered heretical, Copernicus kept his theories largely to himself. Not until late in life was he finally persuaded to explain his ideas more fully in a book called Concerning the Revolutions of the Celestial Orbs. He died in 1543, before it was published, and was buried without fanfare near the altar of his beloved cathedral, unaware of the impact his ideas would soon have.
a little bit of calculations will show that that person there is being spun round at about 1,000 miles an hour and doesn't know it.
The way we view the universe has a profound impact on our understanding of ourselves. Today we see the Earth as a small, fragile globe, orbiting at just the right distance from the Sun for life to flourish. It appears to be the only planet with life in the solar system, and the planets themselves are mere specks in the vacuum of space. Human life seems reduced to insignificance when set against the vast, nearly empty spaces of modern astronomy. But before the modern era, the universe appeared much more comfortable and accommodating. Thus, medieval European cosmology placed the Earth in the center of a small spherical universe surrounded by the abode of God and the elect. The passage of day and night is described in the Bhagavatam as a straight terminator rotating over a plane map, as we see here. Although this does not make sense in a literal plane, it is realistic in the planisphere model, and thus it adds weight to this model. Here we see the ecliptic and the zodiac projected stereographically onto the Earth map. The Sun and zodiac revolve clockwise together once per day, while the Sun moves counterclockwise around the zodiac once per year. Here the zodiac is projected stereographically onto Bhumandala. Note that as the Sun goes around the off-centered zodiac in its yearly orbit, it crosses the ring-shaped islands and oceans of Bhumandala. This ocean-crossing motion is described in the Puranas, and this also adds weight to the planisphere model. Bhumandala can be compared with an astronomical instrument called an astrolabe, which was popular in the Middle Ages. On the astrolabe, the off-centered circle represents the orbit of the Sun, the ecliptic. In an astrolabe, the Earth is represented in stereographic projection on a flat plate called the mater. The ecliptic circle and important stars are represented on another plate called the ret. Different planetary orbits could likewise be represented by different plates, and these would be seen projected onto the Earth plate when one looks down on the instrument. The Bhagavatam similarly presents the orbits of the Sun, the Moon, and important stars on a series of planes parallel to Bhumandala. The orbits of the planets are placed on additional parallel planes. Here we see the Bhagavatam's model of the orbits of the Sun, Moon, and 28 important star constellations. These lie in 3 planes parallel to Bhumandala. The layout is comparable to that of an astrolabe. Seen from the side, we find that the Moon is higher than the Sun, but this is simply an artifact of the astrolabe model. It should not be taken as physical. Seen from above, everything falls into place in projection in an astronomically realistic way.
2,000 years ago, an Egyptian scholar by the name of Eratosthenes performed an experiment that he claimed proved the Earth to be a sphere. However, there are serious doubts about the accuracy of his data and his scientific procedures. Dr. Leo Ferrari explains.
Oh, the Eratosthenes experiment is an experiment supposedly conducted in the 1st century, whereby this ingenious person was supposed to have proved, I say that in quotes, that the Earth was a sphere of some 4,000 miles radius. Eratosthenes one day noticed that the Sun was directly overhead in Syene, whereas he noticed that on the same day, at the same time, the Sun made an angle of 7.2 degrees to the vertical at Alexandria, which was some 530 miles away. How did Eratosthenes in the 1st century know what the Sun was doing on the same day in 2 places which are 530 miles apart? One can take all those same data knowing that the Earth is flat. In one place you have the sun directly overhead, and at another place, at the same time, at 530 miles away, let us suppose that it does make an angle of 7.2 degrees to the vertical. Then we have a right-angled triangle, which it can be easily shown that the sun is a sum of 4,000 miles up in the sky. These superficial, even, considerations show that it's impossible. The whole thing, it's a story, a fairy story made up and mindlessly repeated in textbooks. With a sphere of 4,000 miles radius being spun round once every 24 hours, a little bit of calculations will show that that person there is being spun round at about 1,000 miles an hour and it doesn't know it. I mean, this is obvious nonsense. You go on a merry-go-round and it goes, I doubt, more than 10 miles an hour, and you get off all dizzy. You mean to tell me that people can be spun round at approximately 1,000 miles an hour and not know it? Why, if this is so, this whole room that we're in is supposedly being spun round at something of approximately that order of speed, and we don't know it.